Hey guys, this is Jules. Welcome to my tutorial, Understanding For Loops. This video covers material up to and including Week 5 in the Introduction to Interactive Programming in Python. The first thing we should ask is, why do we use for loops? The most truthful answer is, we don't actually need them, technically speaking. Anything that can be done with a for loop can also be done without one, using simple syntax we've already mastered. So you may be wondering, Jules, if I don't need them, wouldn't my life be much easier if I didn't have to bother with them at all? Let's take a closer look at what for loops do, and you can answer that question for yourself when we're done. Any characters in this tutorial are completely fictitious. Any similarity to real persons, living or strangled by their own neckwear, is purely coincidental and demonstrates a lack of creativity from the writer. Please enjoy the rest of the tutorial, despite this horrific display of subpar talent. Let's start with a simple problem. I have 3 friends, Joe, Scott, and John. I also have a nifty new spaceship. I also have a chihuahua named Noodle, but I digress. Being a good friend, I want to let my friends go for rides in my new spaceship. But there's a problem. My spaceship only seats 2 people at a time. The maximum weight capacity is 350 pounds, and I only have enough fuel for 2 trips. You think regular gas is expensive. Try fueling a spaceship. So I ask my friends how much they weigh. Joe says he weighs 180, Scott says 150, John says 200, and I weigh 130, and not a single ounce over since this is my tutorial. Then I decide to open Code Sculptor and make a nice little program to do the work for me. So I start with my variables. Then I write an if-elif clause to determine who gets paired up. Great! I solved the problem. That was easy. But guess what? I didn't save myself any time at all by making a program. In fact, I made more work for myself because I had to think of every possibility of combinations. Wait, Jules, you might say. Computers are supposed to make our lives easier, not harder. What's wrong here? As I ponder your question, I hear Joe mumble something about hacking rainbows and unicorns, and then Scott informs me he doesn't want to ride with Joe. Oh no. Now how do I have to change my program so Scott doesn't end up getting murdered by one of his own neckties in outer space, where I'm pretty sure a CSI team would have a hard time finding evidence? So now I have to make sure Scott is never paired with Joe. So that means Scott has to be with either John or Jules. I adjust my code to reflect this, and it actually did reduce the amount of lines. Sweet! But writing the code still took longer than just looking at the numbers myself and doing some quick arithmetic in my head. Now you might be thinking, Jules, what does this have to do with for loops? Well, hold that thought, because while flying out in space, Joe informs me that this is the most awesome thing he's ever done, and he wants everyone who signed up for his online class to get a chance to do this too. He says he'll even cover the cost of the fuel because he said he made a bunch of money doing ads for t-shirt companies or something. He then says he'll send me the list of people with their weights when we get back, and not to worry because it's only around 80,000 people, and I already have a program to decide anyway. Clearly, I can't go through every name and write if statements. My code would have to be billions of lines long. I need something that will go through every name in the list. Remember when I said for statements actually aren't needed because anything we can do with a for statement we can do with other methods? That's kind of like addition and multiplication. 3 times 4 is 12. That is just another way of saying 3 plus 3 plus 3 plus 3 equals 12. But try this one. You'll be working on that a while if you use addition. If statements are like addition, then for statements are like multiplication. If statements process one thing. If this one thing is true or happens, then do something. For statements process as many things as we want. For every item in this thing, do something. The syntax for for loops is simple. For, item name, in, thing with items, colon, code block of instructions, which basically means do these things. Things with items can be anything that can be iterated through. Things like dictionaries, lists, tuples, strings, sets, and numbers using the range function. Iterate means to do something again. Item name can be labeled anything you want that is a valid variable name. Although good practice is to pick a name that has meaning for that particular case. Item name is a singular element, whereas thing with items is a collection and usually contains more than one thing. So let's get back to our example. Joe sends me his list of 80,000 students and their weights. It is a list of tuples, but I'll ignore Joe's list for now and make my list in the same format. Before I write out my for statement, I want to clearly understand how the for statement works. To do this, I'm going to write a for statement. Circular logic for the win. I want to see exactly what is happening, so I make a count variable that will keep track of the iterations or loops, and I use print statements to show me the start of each loop. Now I can see exactly what the for loop is doing. First, it gets the first item in my list, which is the tuple Joe 180. It then executes the instructions in order. The count on the first iteration is 1 because the counter is not updated until after the print statement. Then it loops again to get the next tuple, print the information, update the counter, and so on. Once the for loop has iterated over every item in my list, then it stops, and the code continues by finally printing finished. A for loop says to the program, don't move past this section of code until you do this block of instructions for every item in this collection. You might be thinking, Jules, what if I want to break out of the loop early if certain conditions are met? That's what break is for. If we put a break conditional in the for loop so that once we get to John, we stop, it would look something like this. Okay, so back to my example. How do I figure out what code I'll need? This is a good time to think in pseudocode. What is pseudocode? It's more English than code, but less English than prose. It isn't concerned with precise syntax or grammar. Here's a simple example. The point here is that I can think of what I want the program to do without fully thinking of exactly how to achieve that. Another benefit to starting any program with writing it first in pseudocode is that these snippets of instructions can become your comments. Plus, since your notes are right there, it helps remind you where you are and what you have left to do. Okay, so what's my pseudocode for our example? Let's make a rough draft. Problems I already can see. Number 1, I don't want to go through any steps if the name is already part of a match. Number 2, the item is a tuple. If the item was just a count of which element it was, I could do step 1 with something like this. Otherwise, I would need to figure out which tuple I was looking at, and that would probably mean indexing it in some way, and that just sounds complicated. Number 3, am I putting the whole tuple in the list of solutions? Just the names as a pair of names? Number 4, how can I account for people like Joe and Scott that don't want to ride together? Number 5, what if there are an odd number of people, or someone who is too heavy to match with anyone else, or too heavy to ride at all? Number 6, depending on how many people are unmatched at the end, may need to figure out a way to optimize the approach so that the heaviest people on the list are first matched with the lightest or something else. Okay, anyone else here getting intimidated yet? Let's think of this one step at a time. First, I want to build a dictionary out of the list Joe gave me. I feel like that will give me more flexibility in how I can manipulate the data. I want the keys to be the weights, so that way I can group up all the people who weigh the same. Because I know immediately that if someone weighs 250 pounds, they will have to be matched with someone weighing no more than 100 pounds. Then I want to make a new list that is just the different weights people are. Next, I want to sort the list so that the numbers are in order and descending from the heaviest to the lightest. Now I want to make a new adjusted list by first removing anyone that weighs too much to ride or match. Obviously, anyone who is too heavy to ride will by default also be too heavy to match, so I only need to check the one. Next, I will find matches. By building the adjusted list in the previous step, starting with the heaviest people first, I know that when I start iterating through my list, I will be matching the heaviest people first with the heaviest possible person they can ride with. This will help prevent an excess of hard-to-match people later. I also need a way in this step to catch people I can't match. For the next step, I need to group my solutions into pairs of matching people. Since I populated the solutions list with people in pairs, and they were always appended, therefore always added to the end of the list, I know they are beside their match. I can use a range that starts with the first, ends with the last, and counts by 2 to pull these pairs out. Finally, in the last step, I need to report my findings. I chose to iterate over my matches and no match lists to print the details in an easy-to-understand format. After I wrote the code and made sure it seemed to be working, I realized I still hadn't addressed the issue of Scott not wanting to ride with Joe. One thing to learn about coding is that it is an art, and as an art, there is almost always going to be something else you want to add or tweak. Get used to this feeling of forever not being done. But when there's something really important you think the code needs, it is common practice to add commented out sections either within the code, at the beginning, or at the end labeled to do, followed by what the programmer still intends to do. One final comment I'd like to make about for loops has to do with the break command. You can notice in step 5 in my code that I used break. You may also notice that I still was able to iterate through all the people in the list. You might be thinking, how is this possible, Jules? If we break up the code, we can actually see that we have nested for loops, not to mention a ton of nested if statements. So when I call break inside a for loop, inside another for loop, I only leave the innermost for loop. This is a good thing to remember because nesting for loops can be exponentially taxing on your processor. In our example, just think about how many times the code would have looped had I not put the break commands in. The first for loop will run 80,000 times, give or take 1. The next for loop will run 80,000 times, give or take 1, for every run in the first for loop. That's a whopping total of 6.4 billion iterations. Obviously, if you ever nest loops, you want to consider ways to get your answer faster, which is why I ordered my list first. And more importantly, once you get your answer, break out of the innermost loops so you save time. Those microseconds can really add up. So hopefully you understand for loops a little better. I purposely did not use any functions in the Code Sculptor example so I could demonstrate more examples of for loops. This is not the most efficient or elegant solution to this problem, so please don't take it as such. But it is full of many examples of for loops and shows how powerful they can be, especially on repetitive tasks. In fact, I used a for loop for every step except step 3. If you really want practice using for loops, try writing a loop that achieves step 3 without using sort or reverse functions. Thanks for watching my tutorial, guys, and if you liked it, remember to upvote it and comment in the forum post.